Moving on, let's drop down a mocap biped 3, and I'm going to take the T-pose. I'm going to hide this. I'm going to drop down a geometry, delete this, and drop down an agent. And I'm just going to read the mocap biped 3 by going here, mocap biped 3. I have an agent, and then I'm going to rename this clip to T-pose. Alright, okay, so I want to create two collision objects here, so I'm going to drop down a collision layer, and I'm going to create one here, drag it out a little bit, up, and then I'm going to create one for the arm. So now I have these two collision objects, and I'm going to create a constraint. Or actually, I'm just going to define the limits of that constraint, because the constraints is going to be created later. Before, we just used this to create the hard constraints, but now we're going to use the cone twist constraints, which are the most common ones in ragdolls. I just have this little dot here, this is selected. Either I can just click plus and then select it, or I can just click here, and here are my limits. And currently they are very strict, so you can't move at all. And I have this twist value and an up rotation and out rotation. So let's see what these do. So if I start with the out rotation or the up rotation, now it's more obvious what the limits for these constraints are. I have the handle, and obviously the arm will be able to move within this. And right now it's just on one axis, so it's not much of a cone, but let's start with this. Now I just want to test this, so I'm gonna drop down a test simulation ragdoll. But one thing we're gonna notice immediately if we start using this, I just want the arm to be animated and the rest of the guy to be static. But obviously he's just gonna fall down. It's gonna look really weird because we just have a collision object for his chest and his arm. And yeah, not at all what I wanted. So what I just want to have like a partial ragdoll, just this part. And after 16.5, you can specify all the only parts of the agents are ragdoll. To use this, we need to drop down an agent transform group. And if I go in here, so I want it from the shoulder and to the arm. I have this group name, let's call this arm. And then I need to take the root, and then so I'm gonna select this shoulder. So if I go to left shoulder, let's see here, left shoulder, boom. And if I check this show guide geometry, see I get these little spheres here. And these spheres indicate what parts of the rig that are included in the transform group. Let's see if this works. But it won't work just like this. We need to tell the simulation to use it. If I just play it now, it's just going to be like before. But what I can do is that I can allow editing of contents here. So I can go in and find the actual DOPSIM. And then I can go to the state, the ragdoll state. And here you have this little checkbox, partial ragdolls. So I'm going to do that. And then I'm going to select the group here. You get an active group. So I'm going to select the arm group. And everything seems a little bit broken. And the reason for that is it knows that this part here is going to be ragdoll, but it doesn't know what the rest of the part is supposed to be. What you need to do is you need to tell it that this part here will be ragdoll, but this part here will just play a clip instead. So I'm going to select this clip here. You have this clip name. I'm going to select the T-pose, and ta-da! If we go back here and look how this look, and now we can see the arm is just falling down. And also if we look, you can see that it stops within this guide. Cool. And yeah, and obviously if I do it longer, it will fall down here. Cool. And of course we can use the other axis. So if we zero this out and make this minus 30 and 30, we have it in this axis instead. And obviously if I play it now, it won't fall down because it's not allowed to go down anymore. I can go into gravity, and instead of having a value in Y, I can change the axis to Z. And then you will see it's following that guide instead. If I turn the other range back on, you can now see that they form this little cone that constrains the joint. The final part of the cone twist constraint is the twist part, and you can turn that up by changing the twist rotation range. So let's set this to -10 to 10. You can now look at these yellow lines to see what the limits are for the twist. And a really important thing is that this orange up vector needs to be between these twist constraints. Otherwise, the whole arm is just going to be snap in a really weird position. Another thing that you can use this test simulation ragdoll for is to see if you have any weird constraints. Say that this limit would be in the wrong place, and if you remove the gravity and the initial velocity is zeroed out, that means that the only thing that can affect the limbs are the constraints themselves. That means that if anything moves, the constraints are wrong. So in this case, you see the arm would move down just because it's just tried to follow the boundaries. You can see that the arm doesn't snap to its limits, but instead gradually gets there. And that is just because a new feature in 16.5, if this loud initial violation of limits isn't checked, then it will just pop into place. And so you see, like on the first frame, it's just snapped there immediately. And if it would say that you would have a clip, it would transition from a ragdoll. It would just be like a really unnatural snap. Before, you always had to make the limits fairly wide to avoid getting snaps when you triggered from your animation clips, and these wide ranges tended to give you very floppy arms, for example. So yeah, that is a little bit of cone twist constraints, so let's finish this guy up.